To establish this identity, what I need to do is show that the cosine of theta times the quantity tangent theta plus cotangent theta is equal to the cosecant theta. And I'll do that by taking one side of that equation, and it could be either the left or the right in any case, but usually what's easier is to start with what's more complicated and work to what's less complicated. So we'll start with the left-hand side in this case. So here we're going to transform cosine theta times the quantity tangent theta plus cotangent theta, and step by step show how that leads us to the cosecant of theta. Keep in mind when you are showing a proof of an identity that you need to show all of the steps. You can't skip steps because it's the showing of the steps that's actually the answer, not cosecant theta, because you already know it's cosecant theta. It's kind of like spoiler alert. The answer is cosecant theta. So the steps are what you are graded on, not did you get to cosecant theta, although that's important too. So what I'll do is I will take the left-hand side and through the miracle of copy-paste, there we go, it's right there. And so I have that first, and now I'll show my first step. Very often we're using algebra steps as well as the trigonometric identities that we have established already. So cosine theta times tangent theta, that's what we get first. And I put in the dot for multiplication. You can do that or not. It's fine either way. Plus cosine theta times cotangent theta. Okay, so I've distributed, and now what I'll do is I'm going to change the tangent and the cotangent into sine and cosine. That makes it easier to work with the problem. So I'm using my quotient identities. We have cosine theta times sine theta over cosine theta plus cosine theta times cosine theta over sine theta. And now what I'll do, because I can do some canceling here, so cosine theta cancels, just make sure that if you're crossing out, as I just did, you can still see what's underneath, so that way when it's being graded, then people know what you've written there. Okay, so that term simplifies to just the sine of theta plus, and then I have cosine squared theta over the sine of theta. Okay, so at this point, well, I've distributed. It doesn't really seem like I'm all that much closer to getting the cosecant of theta, though. So just keep in mind what your goal is. I know that I need this to just be a single term. So what I'll do now is I'll get a common denominator and then add those fractions together and see what I come up with. And I think that's going to be helpful here. So what I'm doing now is I'm multiplying the first term, sine theta, by sine theta over sine theta, kind of squeezing it in there, and this is over 1. So this way I'll have a common denominator of sine theta. So that means I have sine squared theta over sine theta plus cosine squared theta over sine of theta. So again, you need to make sure that you're showing all of the steps. And now I've got sine squared theta plus cosine squared theta all over sine of theta. So you might think, well, I could have done that all in one step, going from here all the way down to here. But just, keep in mind that I'm looking to see, when I'm grading your problem, have you shown all the steps that are necessary? Well, at this point, I can use my Pythagorean identity to combine together sine squared theta plus cosine squared theta, and we know that that's just equal to 1 itself, so that's 1 over sine theta. And now I can use my reciprocal identity to say, well, this is equal to cosecant theta. And there you go. Final answer. So what is my answer? My answer is let's see, from here all the way to here, right? So, there we go. Okay, so just keep in mind that I need to see all of those steps when you're writing your identity.